Hi everyone, we are back again and we are going to go through our problem set 2 solutions. So let's go ahead and get us started with some probability and statistics questions. So Halloween is approaching soon. I have a bag of candy from Costco that contains, I'm going to say R, basically R goes to 5. R equals 5 for Reese's. T equals 7 for Twix. Snickers equals 8, and sour straws equals 3, and total will equal R plus T plus S plus sour straws. So the first question is, what is the probability to pull a candy that is chocolate or a Reese's? And the second question is, what about a candy that is chocolate or a sour straw? So remember, when we're dealing with the ors, we need to think about basically, when we're looking at probabilities, are these basically mutually exclusive or are they not mutually exclusive events? So remember, if we have mutually exclusive events, meaning that we're going to be dealing with, so for example, if we have probability of A union, I always do this, B. So if we're looking at event A and B here, and then these circles, or these overlap a little bit more. So we're going to be looking at the total events here of A and B. So remember, this is union, so that's going to be probability of A or B. And that's for if they're mutually exclusive. If they're not mutually exclusive, we're going to have to basically look at our intersection, which is going to be B, and that's going to be A and B. So if we have mutually exclusive events, we are going to be dealing with the probability of AUB, and that will just be union B, and that's just going to be equal probability of A, plus probability of B happening. If they're not mutually exclusive, we're going to have to deal with, again, still A union B, AUB, but we're going to have to look at probability of A plus probability of B minus probability of A and B occurring. Because we have to exclude essentially that because they're not mutually exclusive. So we need to get rid of that overlap here. So let's go ahead and, so if I pull a candy that is chocolate or Reese's, these are not mutually exclusive because Reese's is a chocolate type of candy. So my probability of chocolate or Reese's is going to be equal to the probability that I pull a chocolate plus the probability that I pull a Reese's minus the probability of chocolate and Reese's. And that probability that it's going to be a chocolate is going to be what? Well, probability of chocolate is going to be equal to basically R plus Twix plus Snickers divided by my total. I should actually, tote divided by the total. Probability of Reese's is just going to be equal to Reese's over tote. And then probability of basically that mutually exclusive event of chocolate and Reese's is just going to be what? Well, it's just basically that I pull a candy bar that is a Reese's, so it's also going to be, actually the probability of, this is also going to be equal to probability of Reese's as well. So we're actually going to cancel those out. So actually we can figure this one out real quick. So that is just going to be, and actually let's go ahead and let's do this a little bit more defined in R. So we're going to set this up in R. We don't have to do it here, but we'll go ahead and do it together because I want to write this out a little bit explicitly. Control Enter, install, good. Getting all my libraries set up. Control Enter, Control Enter, Control Enter. So we're going to say R goes to, what do we have here? R goes to 5, and then let's enter that. So T goes to 7. Let's enter that. Then let's enter Snickers goes to 8. I know this is exciting, but again, we'll go through this just so that we know. And SS is going to 3 for the sour straws, and then our tote goes to R plus T plus S plus SS, and we have that there as well. Oops. Control Enter. So we're good there. So probability there, that is chocolate and a Reese's, again, will give us essentially that value. So these two are going to cancel each other out. So the probability that I have a chocolate is just going to be Reese's plus that plus that. So our probability will be basically we're going to do Reese's plus Twix plus Snickers divided by tote. And that is our probability here. So that's our first answer. Now we have another question. What about a candy that is chocolate or a sour straw? So probability that chocolate or a sour straw, now we are dealing with events that are basically mutually exclusive. So we're just going to add those two together. So we already have the probability of a chocolate. We have that right here. So let's just copy this. And then what's the probability plus probability of pull a sour straw is just SS divided by tote. And this is going to give us actually value of 1 because there's only chocolate or sour straw. So that should make sense. So good double check. Fantastic. So problem 1 is down. So let's go ahead and let's continue. Let's delete this stuff now that we've gotten kind of the lecture out of the way. So one of the trick-or-treaters grabbed a candy without me looking. So grabbed a candy without me looking and then pulled out 2 Reese's. What's the probability that the first candy pulled out was also Reese's? So this is an example of a conditional probability. And so we're going to actually have to invoke Bayes' theorem. So remember that we have the probability that event or some number of event, basically B. Oops. So we had our Bayes' theorem here. Basically, so some event B sub R given, remember this line means given that A has occurred, is going to be equal to the probability of B sub R times, B sub R times the probability of basically A occurring given that B sub R has occurred over the sum from I equals 1 to N, and R goes from 1 to blah, 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 all the way to N as well. Probability that B sub I has occurred times probability that basically given that probability of A happening given that B has occurred, sub I. And you multiply over through all those probabilities. So let's go ahead and let's set up this particular problem. And we'll go ahead and get moving. So we're going to say, so what are the probabilities? What is the probability that the first candy pulled was also Reese's? So basically, we pull out a random candy. It could be a Reese's. It could be a Twix. It could be a Snickers, or it could be a sour straw. So basically, we have these 4 basically R values or probabilities here that are occurring. So we're asking, what is the probability? So we can have basically these B sub. So I have a B sub R. I have a B sub Twix. I have a B sub S, and I have a B sub SS for the sour straw. So those are basically what can happen. So let's go ahead and first, let's pull out, because we know we're going to have to sum over all these different probabilities of all the different possible basically outcomes. So what is the probability that I pull a Reese's? So again, that the first, again, because this is the kind of the question, is the first candy pulled was a Reese's. So before any conditional event has occurred. So basically before we then pulled out these 2 other Reese's. Well, that would just be my Reese's over tote. What's the probability that I pulled a Twix? It's just going to be Twix over tote. What about probability B of Snickers? It's just going to be Snickers over, et cetera, et cetera, et cetera. So actually, we can define those right now. And it's nice because we already went through the hassle of defining those variables. So I'm going to say PBR. So probably the Reese's is just going to be Reese's divided by tote. I'm going to enter that. Probability that we get Snickers is just going to be set equal to Snickers divided by tote. What about the probability that we get a Twix? So it's going to be T divided by tote. And then we can also do now probability of sour straw divided by tote. And we got all our values there. And hopefully, again, they should absolutely, they should sum to 1. So now comes a little bit of the harder part, or actually the part that kind of can confuse people. So now we have to look at the probability that we pull out these 2 Reese's here, A, given that the first candy was also a Reese's. So this is the fact that was just basically given here. So that's just going to be equal to my Reese's minus 1, right? My total number of Reese's minus 1 divided by my total minus 1 times, because again, we're pulling out 2 Reese's, right? So given that the first candy, B, remember going back over here, given that B has occurred, that the first candy pulled was a Reese's, what's the probability the next one is? And then it's just going to be Reese's minus 2 divided by my total minus 2. Good. Now, what about if it was a Twix? So what's the probability of me pulling out 2 Twixes? So given that the first, actually B sub T, probability here, excuse me. Given that it's a given though that again that the first one that I pulled out was a Reese's. So what's the probability that I pull out? Given the first one was a Reese's, actually we can redefine it a little bit here. So I just want to make this notation a little bit clearer, but it'll be actually as such. Exactly. So what's the probability that we pull out again two Twixes now? So instead of 2 Reese's, 2 Twixes, but still the first candy pulled was a Reese's. So now it's just going to be the probability will be what are the Twix over total minus 1 times Twix minus 1 over total minus 2, right? So here you see the difference. Like we're still subtracting 1 from our total because we pulled out a first candy and it was a Reese's. But the probability that we then pull out, or basically when we randomly grab in that we pull out now 2 Twixes, it's just going to be Twix minus 1 and this minus 1. And the same thing is going to hold for example, the Snickers. So probability A, given that we're doing Snickers, is just going to be Snickers over tote minus 1 times Snickers minus 1 over tote minus 2. So we can go ahead and we can start to calculate that now. So let's go in to R and let's build in that functionality. So we have our PB. So I'm going to call this now PABR, and that's going to be equal to, I'm going to do R minus 1. Should we do a couple of these? R minus 1 divided by tote minus 1 times R minus 2 divided by tote divided by parentheses tote minus 2. Let's see if we get a value from this. Oops. I think we did. Let's see. I think it needs a. I think we need. First of all, I'm going to put this in parentheses here. And I'm going to do a multiply. There we go. PABR. So now I could copy this. So that's for PA for Reese's. Then we'll do the same thing for Snickers. S but now it's just going to be not s minus 1, it's just going to be s, s here, and then s minus 1, and then the same thing for, I'm going to fix this, Snickers. Actually, we'll do Twix. So let's do Twix, PAB Twix, Twix, Twix. Snickers is done, but we can name it Snickers, and then we need to do sour straws, sour straws. All right, so we can do this. Actually, I'm just going to go enter, 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 enter. And now we can go ahead and do and utilize our function. So our function is just going to be simply PBR times PABR. I'm going to do this. We're going to call this PBR A prob. And then we're going to divide that by, and now we're going to get into it right here. So now we're going to sum basically all of those probabilities. So actually we'll start off with PBR times PABR plus, so we're summing it, PBS times PABS, PABS, PABR, plus PBT times PABT plus PBSS times PABSS. And we get that, and then here's the probability. PBRA, BR, that variable. So 0.07, so we have about a 7.3% probability of doing that. Fantastic. All right, let's go and get to number 3. So that was a very, very, you kind of see this procedure, and so we'll move through it quicker next time. But that's how you approach these Bayes' theorems problems. All right, playing with deck of cards. What is the probability that I pull a black jack or black card? So remember, A is going to be a probability of black jack. B is going to be a probability for just a black card. These are not mutually exclusive events. So when we're looking at the probabilities, we're going to have to, again, subtract that intersection, or the and. So we're going to have to do, for example, we're going to do PA plus PB minus PA and B. So what's the probability that I pull a black jack? There's 52 cards. There's 2 black jacks. So 2 over 52 plus a half, right? Minus, what's the probability that I pull a card that is a jack and also black? It's going to be 2 over 52. So I'm just left with a half. Great. What about the probability of pulling a red queen or a clover? So a clover is one suit of a black card. So these are not mutually exclusive events. So I can just do this part, PA plus PB. So what's the probability that I pull a red queen? So that's going to be 2 over 52 plus, what's the probability for a clover? So that's just going to be a 1/4 because it's a 1/4 suit. So there we go. Fantastic. That's our probability there. All right. Let's go ahead and we have a couple more Bayes problems, Bayes theorems. This is quite an intense problem set. All right, let's go ahead. I have a bag that has 17 blue balls, 4 red balls, 21 green balls. I pull out a ball from the flag, don't replace it. The next 3 are all green. What is the probability that the first ball pulled is also green? So we have 3 possibilities here. And so we're just going to run through our Bayes theorem again. So let's go ahead and let's try to define it and write it out. And actually, we can use a lot of the same. We're going to use a lot of the same code that we already built here for these problems. So let's go ahead and we can actually kind of copy some of this to give us a starting point. So we're on problem 4 here. I want to separate this as 2. So blue balls, BB, is going to be 17. My blue balls, red balls is going to be 4. And then my green balls is going to be, green balls will be 21. And then my total will just be those, basically blue ball plus red ball plus green ball. I want to kind of read those in right now. Boom, boom, boom. I want my new total to be this, and so hopefully let's actually double check and let's make sure that our total changes. Obviously, we probably want to change the notation here, but I'm going to be a little bit lazy right now, but we're good. So what's the probability that I get a blue ball, or that we pull out a blue ball? It's just going to be blue ball over total. What's the probability that I pick a red ball? Why do we have triple B? Yeah, PB. Yeah, PBRB. That's just going to be red ball over total. And the probability PB green ball is just going to be equal to GB over total. That's great. And then we can do the same. Actually, it's the same, exact same problem, except now we're going to have 3, right? So when we're looking at trying to figure out, for example, what's the probability that that I'll pull 3 green, given that a green has occurred already, that's just going to be, again, your green ball -1 over tote -1 times green -2 over tote -2 times green -3 over tote -3. And then for the rest of them, it's just going to look fairly similar, but for example, let's do for blue balls, it'll just be equal to blue over tote -1, given that we pulled out the green, and then etc. the next 3. So 1, 2, 3. So we got it. So let's go ahead. Let's get to it. I am going to go ahead and say probability A blue ball, PABB, is going to be my blue ball -1 over tote -1 times my blue ball -2 over tote -2 times my blue ball -3 over tote -3. Blue ball, my PA red ball, actually I'm going to call this blue ball, and then my PAB green ball. And actually, this actually holds for the green ball. So I'm just going to copy this here, green ball here. I'm going to change the blue ball and delete that to green ball, green ball, green ball, because that's correct for that. I'm going to change this to just blue ball -1, or blue ball total, blue ball -1, and then blue ball -2. There we go. And then finally, we'll copy this. We'll put it right there for the red ball. And then red ball, red ball. So see, it's nice to kind of do this. It's always good to kind of build your code out, and then you could use this on the exam too. So make sure. Control Enter, Control Enter, Control Enter, Control Enter. So my PB green balls. So I can do my BGB times my PABGB over the same thing. We can copy that in because we're summing over all of the possibilities here. Plus my PBBB times PABBB plus my PBR red ball times PABRB. So enter that, and there you go. That's the probability. Kind of makes sense too, again, because of the, you have a pretty large number there. But we've got it. Actually, PB green balls, all of this over there. Yep. So that's that one. All right. So we have one more here. Playing a deck of cards, pull out 3 cards and do not replace them. The next 2 cards I pull out 3 cards and I do not replace them. The next 2 cards that are pulled are clubs. What is the probability that all 3 cards are also clubs? Let's go ahead and let me see this here. Cards that pull out 3 cards. Next 2 cards pull. All 3 cards are also clubs. 1 second here. I think we may have an issue. Yeah, actually, we have an issue here. This is an erroneous, or actually, this is not on our problem set. So we will delete that from the problem set. You do not have to do that problem, and that's great. So we'll move on to our last problem here, which is going to be looking at our normal distribution. So we can go ahead and simulate the normal distribution. Again, looking at the population mean, building that in. This is basically the same thing that we've done in our lecture as well. So let's go ahead and let's take a peek at this. So we're just going to take samples and see how well it approximates the mean. So we can go ahead and I'm going to clear everything that we have right now in our environment. And the point of this exercise is just to see, here's our normal distribution. We're going to grab samples 1, 10, 20, and you'll see how well, again, it should approximate the mean, which is 36. So if I grab one sample, 36.9, it's good for just a random sample. Watch if we pull it again, it's probably going to be worse. Ooh, what about this? See, yeah, so you can see different values. But as we increase and we get higher and higher, we get closer and closer to that 36 value. So increase your sample size, increase the probability, or increase your ability to more accurately represent the population. So that's why we want to collect large sample sizes. Thanks, and we'll see you all next time. Bye.